So in this video, we're going to be exploiting a program that I made to demonstrate House of Botcake. So since we're working on a modern glibc, in this case glibc 2.35, we need to bypass safe linking in order to overwrite the tcache FD. So safe linking is defined here in glibc malloc source code. What reveal pointer will do is it'll take the position and shift it by 12 and then XOR it by the pointer, where position is the location of the current chunk and pointer is the chunk that we are pointing to. So in order to bypass safe linking, we'll basically just do the same thing when we overwrite the tcache FD. So let's start off with some initial RE of the program. We see that it calls setBuff on std and stdout and stdr. This looks like a menu. So we'll rename that to menu. Retype this. Rename this to choice. And then option. Retype this as well. So let's see option 1. Okay, and it seems to have a struct. So let's start analyzing these functions here too. We can retype this. So this is allocate a chunk. This seems to get an index. And this reads to a new line. Alright, so let's make a struct. Where is it? Types. And this chunk pointer. Even int size and wolf read, because we have a chunk pointer, a size, and it seems to be setting this to 0, indicating that it's some boolean. So let's retype this struct. Before I do that, let's change this to size t. Oops, didn't do that. Just there we go. Size t. Okay. And then let's give this chunk. Alright, well, it's not working. I don't know why, so let's just like manually retype that. Enter to chunk. uint 64t size Wilfried. Nice. Let's also that there. Oh. Well, I guess Binja doesn't like that, whatever. Okay, so we know what this function does. Let's go back to main. Alright, let's check out this one. Alright, so this is freeing a chunk. Yeah, I'm not liking that. So I think we need to retype this. Free chunk. And then there we go. Okay, that looks a lot better. So let's check out this one. Okay, this is writing to a chunk. There we go. It's all better now. Nice. Okay. And we'll rename this display chunk. Okay. So we can allocate chunks, we can free chunks at will, we can write to any chunk, and we can display the data inside of any chunk. So the primitive that we have here is a double free, and we can also leak data off the heap. Okay, so let's quickly review my exploit script. We have our class for program interaction here, where we can malloc free show any chunk and write to chunk. And we have our mangle functionality to bypass safe linking. We'll first fill up the T cache. This is the start of the House of Botcake primitive. We allocate a chunk for consolidation and a victim chunk, and then we add a padding chunk so our overlapping chunk doesn't get sucked up in the top chunk. And then we're going to cause overlapping. We free 7 chunks so that the T cache gets filled up, and then we get a heap leak showing the first T cache FD, and then we calculate the base address of the heap. We're going to free the victim chunk so that it gets added to the unsorted bin, and now we have a libc leak, and then we rebase libc. And then we're going to free the consolidation chunk so that we have an overlapping chunk. Now, this is where our T-cache poisoning primitive comes into play. We're going to add a chunk. We're going to add the victim chunk to the T-cache list by taking one out from the T-cache and then freeing the victim again. Allocating any size larger than 0x100 will change the FD pointer into a T-cache chunk. So now we're going to forge our fake chunk. Our fake chunk is located at the base address of the heap plus 0xb10. And then we're going to overwrite the libc got plt. And our fake forward pointer will be libc got plt and fake chunk passed into protect pointer, basically. we're going to be mangling it. And then we're going to write to chunk. We're going to be writing to our overlapping chunk, so our fake chunk. And then we're going to pad out the start of it because we need to pad out the overlapping chunk, right? So we're going to pad it out and then set our size field to hex 100, basically. Hex 111. And then we're going to write our forward pointer. So this is our T-cache poisoning. And then we're going to allocate a chunk, and then we're going to allocate another chunk so that this chunk will end up forcing malloc to return an arbitrary pointer, which we can write to. And then we're going to write binsh a bunch of times, and then libc system, which will pop us a shell. There we go. Also, we recently reached 100 subs, so if there's anything that you guys want me to do or something, just let me know down in the comments, and we'll figure something out. Thank you, everyone.